Next in the unit, we're going to be solving exponential equations. So if you look on your notes, there are two questions. The first one says, how do I solve exponential equations when the bases are the same? And if we look at an example, you'll probably see pretty easily how to do that. So if I have 3 to the x equals 3 to the 7, when the bases are the same, you can tell that the exponents must equal each other. And so I'll set up the equation x equals 7. And normally there'd be an equation to solve. This is a really simplified example. And so just the final answer would be x equals 7. That's the solution. If we were to do one that's a little bit more complicated, let's say I had 2 to the 3x multiplied by 2 equals 2 to the 8th. This is another circumstance where we have all the bases are the same. Well, the first thing I need to do is combine these two into one piece. And if you guys remember the properties of exponents, it's when the base is the same, you can add the exponents together. So I need to remember that the 2 that's there that has no exponent, it really is an exponent of 1. That's a 1, not a check. There's a 1. And so I'm going to go ahead and rewrite that problem with those exponents added together. So 2 and then 3x plus 1, I'm just going to write as 3x plus 1. So there I am adding the exponents together, equals 2 to the 8th. And now I know that since the 2's match up, then those exponents must be the same. So I'm going to basically ditch the bases, and I'm going to solve the equation 3x plus 1 equals 8. So I will go ahead and minus 1 from each side. 3x equals 7. And then I'll divide by 3 on each side. And so x equals 7/3. And these answers are really easy to check. You could go into your calculator and plug in 7/3 for x, or you could graph these and then see where they intersect and make sure that 7/3 is the right answer there. All right, next on your notes, it asks the question, how do I solve exponential equations when the bases are different? And then you see this chart. And so on this chart, we see a bunch of different bases and their exponents. And what we will do is we're going to use this chart to change the bases so that they actually are the same. So on the chart, I'm going to go ahead and start with the 2's. We're going to fill out some of this together. And if you recall, I'm going to start off with 2 to the 0. Anything to the 0 power is always 1. So this is going to be 1, 1, 1, all the way across. These are all something to the 0 power. 2 to the first power is just plain old 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. 2 to the seventh is 128. So all those values you can go ahead and fill in. When you start doing negative exponents, I don't know if you guys remember, but a negative exponent makes that number move to the bottom of a fraction. So 2 to the negative 1 is actually 1/2. 2 to the negative 2 is actually 1/4. 2 to the negative 3 is 1/8. And 2 to the negative 4 is 1/16. Go ahead and pause the video and take a moment to fill out the rest of that table. Okay, so underneath here, go ahead and write a note to yourself. We're going to rewrite the problem. So the bases are the same. So, for example, if you had 2 to the 2x equals 8 to the 4, you would want to see what column 2 and 8 are in, because those are the bases that we have currently. So 2 and 8, we're looking for that column. So if I look at this, 2 and 8 are in the first column. I can see a 2 right here and an 8 right here. So that means that 2 is going to stay as a base of 2. That means I don't have to change it at all. But 8 is going to become a base of 2. It's going to be 2 to the third power. So the 2 to the 2x, that stays exactly the same. The 8 I'm going to rewrite as 2 to the third, but I still have that exponent of 4 on the problem. So 2 to the third is basically 8, so I still have 8 to the fourth. But I've just rewritten it. So 2 to the 2x, I don't change that at all. Now this part, if you guys remember, an exponent raised to an exponent, we use the properties of exponents, we multiply them together. So 3 times 4 is 12. So this is 2 to the 12th. So now that the bases are the same, I can go ahead and ditch them. And now I have the equation 2x equals 12. I'll divide by 2 on both sides, and I'll get x equals 6.